This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll discuss about the Karnaugh map method of simplifying the Boolean expression up to 5 variable key map. We'll see how to construct, first of all, we'll see the limitations of Boolean algebra and why we are going for the Karnaugh map, and then how to construct a K map, that is Karnaugh map of 2 variable, 3 variable, 4 variable and 5 variable, and what is the procedure and how to simplify a Boolean expression using K map and some example problems on it. So first of all, let us see the limitations of Boolean algebra. So Boolean algebra helps us simplify the expressions and circuits, but here it is having a drawback that it doesn't have any systematic procedure. That means it doesn't have any systematic approach for simplifying the Boolean algebra. We need to apply the Boolean algebraic postulates and theorems randomly, and we have to get the simplified Boolean expression. So that is the major drawback. So we don't have any systematic approach. So as we don't have any systematic approach, the simplified expression may not be unique. So one person will get one simplified expression and the other person will get another simplified expression. Based on the theorems and laws which you apply, you will be getting the simplified expression. So that means as we don't have any systematic approach, so the final simplified Boolean expression may not be unique. So, and it is complex to apply. We remember and apply the laws of Boolean algebra for simplifying the Boolean expression. So this is what, and as the complexity becomes more, so it is very difficult to simplify the Boolean expression by applying the laws and theorems. So these are the limitations of Boolean algebra. So that is why we are going for the K map. So it is a systematic way of simplifying the Boolean expression. So K map is derived or invented by a scientist named Karnaugh, and hence this method has come after his name. And in short, we can also call it as K map. Karnaugh map, in short, it is also called as K map. So K map is a graphical technique for simplifying a Boolean expression into either of the form. So as we have two types of expressions, that is sum of products form and product of sums form. So this is a graphical technique for simplifying a Boolean expression into either of the form, that is minimal sum of products form and minimal product of sums form. So as we all know that sum of products and product of sums, but minimal means by using this K map method, we can get the minimized or else simplified expression. So that is why we are calling it as minimal SOP and minimal POS. And the major goal of the simplification, first of all, why to go for the simplification? Either we use Boolean algebra or we use K map or we use tabular method, whatever it is, what is the goal? Why we are going for this simplification? So this simplification, the major aim of the simplification is minimal number of, in order to get the minimal number of product terms or sum terms. That means in order to reduce the number of terms in a given expression, the terms may be either of the form, that is product form or sum form. And each term, and another goal is also, if we are not able to reduce the number of terms, if we can reduce the number of variables or literals, that also gives you the simplified expression, so that the number of components required to implement a Boolean expression will be reduced, and hence the cost is reduced and it is very easy to implement. So these are the goals of simplification. So the goals are in order to reduce the number of product terms or sum terms, or else at least if you can reduce the number of variables or literals, that also gives us the simplified expression, which is possible by using either of the minimization techniques, that is Boolean algebra or K-map or tabular method. So just like a truth table, K-map contains number of cells. So each cell represents one of the possible combinations of input variables. So for example, if we have n variable function, so what are the possible number of input combinations we may have? That is 2 power n. So for each combination, we'll have a cell in the K-map. So that means each cell, that a K-map, an n variable K-map will have 2 power n cells, and each cell or else each square represent one of the possible input combinations of n variable. 2 power n possible input combinations of n variable Boolean function. So however, K-map, the values are stored in the cells of array. In each cell, the binary value of each input variable is stored. The K-map method is used for expressions containing 2, 3, 4 and 5 variables. So that means here the use of K-map is simple up to 5 variables. So when the number of variables increases beyond the 5 variables, the complexity becomes again more, and hence the simplification may not be accurate. So that means up to 5 variables, we can simplify the Boolean expression perfectly using this K-map. For a higher number of variables, there is another method we have, that is Quine-McCluskey method or tabular method. So that means more than 5 variables. If you want to simplify a Boolean expression, then we can go for the other method, that is Quine-McCluskey method, or else we can also call it as tabular method. In K-map, the number of cells is equal to the total number of input combinations. Okay, so that means, for example, if we have 3 variables, that means if a function is of 3 variable function, then how many possible input combinations we'll have for a 3 variable? If we have 3 inputs, then 2 power 3. So that means in that such kind of function can be simplified using 3 variable K-map, where in the 3 variable K-map we'll have 8 cells. We'll have 8 cells, and each cell represent one of the possible combinations of 2 power 3, that is 8 combinations of input. And the K-map takes, that means we can simplify either SOP or POS form of Boolean expression, whatever it may be the form of Boolean expression. Either the expression is in sum of products form or product of sums form, we can simplify that expression using K-map. So only the thing is, if the function is in terms of SOP, then each cell should be filled with 1 for the respective minterms which are present in the Boolean function. If you are simplifying a Boolean expression which is in the form of POS, so that means it will have max terms. So max terms produces the function output as 0, and hence if you are simplifying a POS form using K-map, each cell for corresponding the max term should be placed with 0. There are the following steps used to solve the expressions using K-maps here. So here, one more thing. First, what we need to do? We need to map the Boolean expression with the K-map. So how can we map the K-map, a Boolean function with the K-map? So first we need to identify whether it is in SOP form or POS form. If it is in SOP form, it consists of minterms. So all the minterms we should place in the cells for the respective minterms which are present in the given expression with 1. And the remaining we should leave as it is. Okay, why we are placing 1? Because the function is in SOP. So all the minterms will produce the function output as 1. Function output will be 1. If it is in POS form, it consists of max terms, and it indicates that for all the max terms that are present in the function, the output is 0. The output is 0. So that is why the respective cells we need to place either 1 or 0 depending on the form of the Boolean function. Either it is SOP or POS. So once the Boolean function is mapped with the K-map, then we need to follow some steps in order to get the simplified Boolean function. What are the steps here? So first we find the k-map as per the number of variables. So that means looking at the Boolean function, we need to identify how many variable Boolean function it is. So based on the number of variable, we need to take that many number of variable k-map. For example, a function is of 2 variable, then I have to take 2 variable k-map. If a function is 3 variable, then I have to take 3 variable k-map. I will show how to draw the k-map. After identifying the number of variables, find the max terms and min terms given in the expression. So in the given expression, we need to identify whether it is SOP form or POS. That means we need to identify whether the function includes max terms or min terms. Once we have identified the form of expression, then fill the cells of k-map for SOP with 1 respective to the min terms. For all the min terms which are present in the expression, we need to place the 1 in the k-map with of respective cell. And similarly, if the expression is in POS form, we need to fill the cell with 0 for the respective max terms presented in the Boolean function. Next, we need to, so after mapping the Boolean expression, this is what mapping the Boolean expression with the k-map. After we map with the Boolean function with the k-map, then what is the next step? We need to create rectangular groups. So that groups contain total terms in the powers of 2, like 2, 4, 8, 16, 32 and so on. So that means what we are doing, it means that we have to group the adjacent cells. What do you mean by adjacent cells? So here we need to say that the cells are said to be adjacent cells. So what do you mean by adjacent cells? The cells, 2 cells are said to be adjacent if they are differed by only 1 bit position. If they are differed by only 1 bit position, then those 2 cells are said to be adjacent cells. So whenever we are grouping the cells as a group of 2 cells, 4 cells, so this grouping should be done as a power of 2. So that means I can group 2 cells, which is a 2 power 1, where I can also group 4 cells which are adjacent to each other. So because it is 2 power 2, but I cannot group 3 adjacent cells together. Only I have to group the adjacent cells such that the number of terms will be powers of 2. That means I can group 2 cells or 4 cells or 8 cells which are adjacent to each other. And we need to check that all the min terms or max terms are covered by minimum number of groups. That means the grouping should be done such that with minimum number of groups, I can cover all the min terms present in the k-map so that I can get the minimized expression. Now, why we need to group and what we are going to do after grouping? So I'll tell you. With the help of these groups, we can find the product terms and sum terms, and sum them up for SOP form. Similarly, we can also find the sum terms and we can product them up for POS form. So now, we have to find the product terms. How can we find the product terms? So, what we are doing? We are forming the groups of 2 cells or 4 cells or 8 cells. So, the group of 2 cells. So, group of 2 adjacent cells is said to be a pair. And similarly, group of 4 cells is said to be a quad. And group of 8 cells is said to be an octet. By forming the group, so min term means, for example, if my min term is having 3 variable, so by forming a group of 2 cells, I can eliminate 1 variable. one variable. By forming a quad, I can eliminate two variables, and by forming an octet, I can eliminate three variables, and by forming a group of 16 cells, I can eliminate four variables and so on. So that means in each minterm, if I can form a group of two cells, I can eliminate one variable. Which variable I can eliminate? So as I told you that, so the group of adjacent cells, so where adjacent cells are the two cells which are differed by only one variable, and the remaining variables are common to that two cells, right? So the variable which is varying, we should eliminate. So like that, by forming a pair, I can eliminate one variable which is differed to the two cells which we are grouping. So that means the variable which is varying for the cells which are grouped together, I can eliminate that variables. And I have to consider only the common variables, and I can form the product terms by taking the variables in true form if its value is 1, by taking the variable in its complemented form if its value is 0. Similarly, I can also form a sum term by eliminating the variable which is varying and considering only the variable which are common to the cells which are grouped together, and taking the variable in its true form if its value is 0, and variable in its complement form if its value is 1, and ORing all the variables together so that a sum term can be formed, so that we can implement the POS expression. So this is the next step. So what we are doing, first mapping the Boolean expression with the K-map, and then grouping the adjacent cells as a power of 2. That is, I can group two adjacent cells or 4 or 8. So by forming a group of two adjacent cells is nothing but pair. So by forming a pair, I can eliminate one variable which is varying for the two cells, and only I have to consider the variables which are common to that two cells. And similarly, by forming a quad, that is a group of 4 cells, I can eliminate 2 variables. Group of 8 cells, I can eliminate 3 variables. Group of 16, I can eliminate 4 variables. So why I am eliminating the variables which are varying? Because my aim is to simplify the Boolean expression. So this is the algorithm or else steps procedure for simplifying a Boolean expression by using the K-map. Now let us see how can we draw the. So as I told you that depending on the number of variable, the K-map will be varying. So here first of all let us consider a 2 variable K-map. So the function may be of n number of variables. That is, it may have 2 variables or 3 variables or 4 or 5. So depending on the number of variables present in the function, the K-map will be varying. First we'll see how to draw the 2 variable K-map. So as we all know that 2 variable function has 4 possible minterms or max term. So I'm just considering the minterms. So similar way we can also do for max terms also. So 4 possible minterms here. So for each of the input combination we can write a minterm as well as a max term, right? So we can, so that means in order to form a 2 variable K-map, as we have 4 input combination, I need to have a K-map of 4 cells. So this is the 2 variable K-map which is having 4 cells, and we have to divide the variables like this. So X is considered as rows and Y is considered as columns. So it is arranged like an array. Okay, X as rows and Y as columns here. So we have 2 rows here because X value may be either 0 or 1. Similarly, Y value may be either 0 or 1. So that is why we have 2 columns. One for 0, Y value of 0 and one for Y value of 1. So this is a 2 by 2 array. So where this is X is equals to 0 and X is equals to 1, Y is equals to 0, Y is equals to 1. So now what I can do, what is the value of X and Y for this cell? 0, 0, and for this 1, 0, 1, because X value is 0 for this entire row, whereas Y value is 1 for this column. So this is 0, 1, and now X value is 1 for the second row. So 1, whereas y value is 0. So 1, 0, and this one is 1, 1. So I can draw this here. So it is a two variable K map. So x, y, x as rows and y as columns. 0, this is 1, and this is 0, this is 1. So this value is the cell binary value of this cell is 0, 0. This cell is 0, 1, 1, 0, 1. Right? So here we have as I told you that each cell represents one of the possible input combination. So here, as we have two variables, we have four combinations 0, 0, 0, 1, 1, 0, 1, 1. So here, this cell represents 0, 0. This cell represents 0, 1, 1, 0, 1, 1. So I can write the minterms. So this can be represented as a minterm or max term. So first of all, I am writing the minterm here, x bar, y bar. Whenever we are writing the minterm or product term, 0, if a variable value is 0, it should be taken in its complement form. If a value of variable is 1, then it should be taken in true form. So this is minterm, and max term. Max term will be opposite. So that is sum term. I can write the sum term by taking variable in its true form if its value is 0. So this is x plus y, x complement y complement. That means this cell represents a minterm x complement y complement and also a max term x plus y. And this one represents x complement y or x plus y complement. And this one represents xy complement, and this is x complement plus y. And this one is xy or x complement plus y complement. So these are the minterms and max terms represented by each cell in the two variable K map. So this is the two variable K map. So now, we can, so this is a two variable K map construction. So two variable K map consists of 4 cells. It is represented as an array of size 2 by 2. That is, we have 2 rows and 2 columns. So this is a two variable K map. And each cell represent one of the possible input combination and also the minterm or max term for that respective input combination. So now we can easily see that which minterm contain common literals. So here, if you see the rows, here first row is having x value as common. Whereas for the first column, y value is common, which is y complement. Okay, so this one and here, if you see the second row, so second row for all the cells of second row, x value is common, which is equals to x. Whereas again columns are same. First column, for all the cells of first column, the y value is 0. For all the cells of second column, y value is 1. So this is the common values. So now here, make few rectangles. So as I told you that once the K map is mapped, Dundigal expression is mapped with the K map, then what is the next step? We need to form the groups of adjacent cells. So here now one second, if you see this one, so what is the value of binary value represented by this cell 0, 0. So this one is 0, 1. How many variables it is deferred? It is deferred by only one variable. So that is why these two are said to be adjacent cells. Whereas these two, so 1, 0, 1, 1. LSB is same where MSB is same, LSB is different. So these two are also said to be adjacent. Similarly, these two are said to be adjacent and these two are said to be adjacent. Whereas if you look at diagonally, so 0, 0, 1, 1. How many variables it is deferred? It is deferred by 2 variables. So these two are not said to be adjacent. So that means, so what I want to say here is, the two cells which are neighboring to each other, row wise and column wise, are said to be adjacent to each other because they are deferred by 1. Whereas diagonal adjacency is not possible. Row wise adjacency and column wise adjacency is possible, but column wise adjacency is not possible. So diagonal wise adjacency is not possible because they are deferred by more than one variable. So that means I cannot group diagonally. I cannot group the cells diagonally. I can group the cells either row wise or column wise. That thing you have to remember. So the maximum possible group that we can form in a two variable K map is, I can form a group of 4 adjacent cells. So because this cell is adjacent to this one, whereas this cell is adjacent to this one, and this is adjacent to this, and this is adjacent to this. So that means all the 4 cells are adjacent to each other in any other way. So in that case, I can group all that is the maximum possible group that we can form in a two variable K map is, it is equals to, that means a group of all the 4 cells. If I group all the 4 cells, what does it mean? So it is either 1 or it is 0. That means a group of 4 cells may give the function value as 0 or function value as 1. This happens in the case of this happens in the case of POS, okay, and this happens in the case of SOP. Okay, so this is why, because when we are forming a quad group of 4 cells, how many variables I can eliminate? I can eliminate 2 variables. Actually, I have only 2 variables. If I can eliminate all the 2 variables, the function value may be either 0 or 1. If the function is given in SOP form, then the function value will be f is equals to 1, f is equals to 0. If all the adjacent cells have received either 0 or 1, I can group them together. So this is maximum possible. And now make each rectangle and overlap. So even we can form overlapped groups also. Overlapped group means what? So here, for example, I have 1, 1, 1 like this, x, y. So already I have formed a group with these 2 cells in order to cover this one. Whereas this one is left free. But here it doesn't have any other element other than this adjacent cells. So this is nothing but overlapping of groups here. So even we can form overlapped groups. So this is 0, 0, 1. So this is how you can group the cells by overlapping one another, such that the more simplified expression can be obtained. And even minimum number of that means, as I told you, that I can form a group with these 2 such that a pair is formed. I can form a group with these 2 such that a pair is formed. Even I can form a pair with this like this. So what are the possible combinations of? So here, as I told you, that min term is represented with M0, M1, M2, M3, right? So now let us consider, this is my 2 variable K map, x, y, 0, 1, 0. So this is 0, 1. So this is M0, M1, M2, M3, right? So what are the possible groups of pairs that I can form here? I can form a pair of M0, M1, okay? And one more, I can also form a pair with M0, M2, and I can form a pair with M1, M3, okay, and next M2, M3. So these are the 4 possible pairs that I can form in a 2 variable K map. So M0, M1 I can form a pair, and similarly I can form a pair of M0, M2 and M1, M3, because these are also adjacent, and I can also form a pair with this one. These are the maximum possible pairs that we can form in a 2 variable K map. So now let us consider, so make rectangles and group of 1 or 1, 2, 4 or 8 ones. Okay. So all the ones in the map should be, in the K map should be included at least one rectangle. Do not include any of the zeros. So that means if you are grouping all the ones, then you should not include any zeros. You should not include any zeros. If you are grouping zeros, then you should not include any ones. So that means either you can group the cells of zeros or cells of ones, but we cannot group zeros and ones in combination. That is the thing you have to remember. Whenever you are grouping the cells of ones, then group only cells of ones. Exclude zeros. When you are grouping zeros, only group the zeros. Don't consider ones. So each group corresponds to one product term. So these are the possible combinations of pairs that we can form in a two variable K map, as I told you that M0 M1, M0 M2 M3, M0 M2 M1 M2. So that is about two variable K map. Now let us consider a three variable K map. So three variable K map. So what are the number of combinations we have? 8 combinations. We have 8 combinations. 2 power 3, 8 combinations. So that is how many cells I should have in a K map? 8 cells I should have. So this is the three variable K map. We have 2 rows and 4 columns here. So 2 rows are representing a variable X, whereas 4 columns are representing the variables Y and Z. And here 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Actually, the X, Y, Z, the combinations will be varying from 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. And similarly, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the 8 possible combinations. So actually I should take this order. YZ values are 0, 0, 0, 1, 1, 0, 1, 1. So but I'm not taking in this order. I'm taking in the other order, which is 0, 0, 0, 1, 1, 1, 1, 0, which is nothing but the gray code of this 2-bit binary number. So what is the gray code here? 0, 0. So how to convert this one into gray code? This is binary gray. So MSB is same. So 0 XOR 0 is 0. 0, 0 XOR 1 is 1. So 1 XOR 0 is 1. So next 1, 0, MSB is 1, 1 XOR 0, this is 1, 1. So 1 XOR 1 is 0. So instead of taking the values of variables in binary order, we are going to take them in gray code. Why we are taking them in gray code? So actually 2 neighboring cells should be adjacent. So if I consider this as 0, this as 1, 0 and 1, 1. Okay. So example, I'm taking another K map here. So this is another K map. So where I'm taking the values of YZ in binary order. So I want to show why I'm taking in gray code. Why I'm taking in gray code. So what is the value? Binary representation X value is 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. This is 1, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1. Now if I take this 2 cells, now how many variables these 2 cells are, which are neighbor to each other? How many variables these are differed? 0, 0, 1, 0, 1, 0. 2 variables are differed. So even though they are neighboring, so I cannot say these as adjacent because they are differed by more than one variable. Even though they are neighboring, I cannot group these 2 cells together because these are not said to be adjacent. So that is why in order to make 2 neighboring cells as adjacent, so instead of following the binary code, I'm following the gray code. Whereas in this one, if you observe 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. Now, these 2 cells are said to be adjacent because these are differed by only 1 bit position, and these 2 cells are also said to be adjacent because these are also differed by only one variable. Whereas these 2 are said to be adjacent. But here, these 2 are, even though they are neighboring, but I cannot say these as adjacent because they are differed by more than one variable. So, in order to make 2 neighboring cells as adjacent, instead of following the binary code, I am following the gray code for assigning the values to the binary variables. So that is why we have to follow the gray code. This point we have to remember. Okay. So 0, 0, 0, 1, 1, 1, 1, 0. Don't put 1, 0 here and 1, 1 here. It is 1, 1, 1, 0. We have to place them in gray code order. Now, this is 0, 0, 0. So, and hence the min term represented by this one is M0, M1. And what is the equivalent here? 0, 1, 1, which is nothing but 3. So, I am writing this one as M3, M2, M4, M5, M7, M6. This order we have to remember. 0, 1, 3, 2, next 4, 5, 7, 6. So, this is the 3 variable K map. Even we can also draw the 3 variable K map in another way. I'll show you how to draw. So now, what is a maximum possible group that I can form in a 3-variable K-map? So I can group all the 8 cells if they are marked with either 0 or 1. So if it is an SOP, if all the cells have marked with 1, then I can form a group of 8 cells, which is nothing but octet. So I can eliminate 3 variables. In that case, F can be written as 1. In case of POS, if all the cells have marked with 0, then I can form a larger group with all the 8 cells, and hence the function output is considered to be 0. So that is the maximum possible group that we can form in a 3-variable K-map. And the next maximum possible group is group of 4 cells. So there are some of the combinations, all the possible combinations of groups that we can form with 4 adjacent cells. So what are that? So this cell is adjacent to this is adjacent to this is adjacent to this. So that is why, and finally this is adjacent to this one, because 0, 0, 0, this one is 0, 1, 0. So that means all these cells are said to be adjacent. So I can form I can form a quad here. I can form a quad here, and even I can form a quad with lower row, and I can form, this is adjacent to this is adjacent to this is adjacent to this, and this is adjacent to this. So I can form another quad, and even overlapping is also possible. So I can form a quad with this, and I can form a quad with this, and even I can form a quad with this last row, and first column and last column, and even I can form a quad with this corner elements, because this corner element is adjacent to this corner element is adjacent to this, whereas this is adjacent to this is adjacent to this. So that is how I can form these many quads here. So first one, M0, M1, M3, M2 I can form, and the second one, M4, M5, M7, M6. So this is one, and next M0, M1, M4, M5. This is the another one, M0, M1, M4, M5. So I will show you the quads here. So first quad I can form here is with this, and the second quad with these 4, and the next thing is I can form a quad with these, and then M1, M3, M5, M7. This is the next thing. Okay, and the next one is M0, M3, M2, M7, M6. M3, M2, M7, M6. And next up, I can also form a quad with these 4 adjacent cells, that is M0, M2, M4, M6. Okay, and even I can form I can form a quad with these 2 also, M0, M4. So that is what, M0, M4, M2, M6. So these are the possible quads, and even we can form pairs. These are the possible pairs I can form, M0, M1, all the adjacent cells. These two, these two, these two, these two, these two. So like that, these are all the possible pairs that I can form in a 3-variable K-map. So if x is equals to 0, then 3-variable K-map becomes 2-variable K-map. Okay, so this is the 3-variable K-map. Okay, so I hope it is clear. So I told you that in other way we can also draw the 3-variable K-map. I'll show here. So the 3-variable K-map we can also write like this by taking 2 columns and 4 rows. So we have to take, and one thing you have to remember, the order we should take as same which is mentioned in the Boolean function x, y, z. So 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 1. So like that also we can do it. So this is M0, this one is M1, this one is this one is M2, and this one is M3, because this is 0, 1, 0, 1, 0, 0, 1, 1. This is 0, 0, 0, 0, 0, 1. And this one is 1, 1, 0, 1, 1, 1. 1, 1, 0 means M6, 1, 1, 1 means M7. And this one is 1, 0, 0, 1, 0, 1. That is M4, M5. Like this also we can form. we can draw the three variable K. So this is the three variable K map. And now next thing, four variable K map. So four variable K map, how many input combinations we have? 2 power 4, which is 16. 16 combinations we have. So that means I need to have 16 cells in order to represent all the 16 combinations of inputs. So this is a four variable K map which is having 2 rows and 2 columns. So totally each two rows are used to represent two variables, and four columns are used to represent two variables yz, wx, yz. Either you can take a, b, c, d also. Whatever the variables you want, you can take it. So, but the order should be same as mentioned in the function or else in the truth table. So again, we need to take the values of variables in gray code. 0, 0, 0, 1, 1, 1, 1, 0. Here also the same thing. So this is 0, 0, 0. All the variables are 0. So M0. This is M1, M3. So we have to remember the order. 0, 1, 3, 2, 4, 5, 7 first, 6 next 8, 9, 11, 10, and then 12, 13, 15, 14. Right? So this is the four variable K map. So what is the maximum possible group that we can form in a four variable K map such that the function f is equals to 0 or 1? So that is 16 adjacent cells. If all these are marked with 0, then I can form a group of 16 cells and I can write f is equals to 0. If all the cells are marked with, this is nothing but POS. If all the cells are marked with 1, that is SOP, then in that case I can form a group of 16 cell and I can write f is equals to 1. And then what is the next highest possible group? That is 8. Group of 8 cells. What are the groups of 8 cells that I can form? So these 4 are said to be adjacent and these 4 are said to be adjacent. This is adjacent to this, adjacent, adjacent, adjacent. So that means anyhow all these 8 cells are adjacent to each other. So I can form an octet with this. And even I can form an octet with these 8 cells. Right? Even I can form an octet with these 8 cells. This is row wise. Similarly, I can also form an octet column wise also. So column wise. So I can form a group of 8 cells column wise also. Okay. And similarly, we can also form an octet with all these 4 cells. 4 cells. So 8. How many possible octets we can form here? And we can also form an octet with these 4 and these 4. That is first row and last row, first column and last column, because all these are adjacent to this last column. First row elements are all adjacent to last column. So now how many octets are possible here? This is 1, 2, 3 and 4, 5, 6 and this is 7 and this one is 8. 8 possible octets we can form. 8 octets we can form. Once the octets are done, what is the next highest possible group? That is group of 4 adjacent cells which are neighboring to each other. I can form group of 4 cells. After forming the 4, if it is not possible to form the group of 4 cells, then we can go for the pair. Okay, so that means whenever we are grouping the adjacent cells, we need to start from higher groups. So first we need to start from higher groups. If it is not possible to form higher group, then go for the next higher group. Then go for the next higher group. Like that, we have to make groups of adjacent cells starting from higher group to the lower group. Okay, and so this is a 4 variable K map here. And now coming to the 5 variable K map. So 5 variables are W, X, Y, U, V, W, X, Y, Z. V, W, X, Y, Z. So actually 32 combinations we have. So for the first 16 combination, V value is considered to be 0. And this 0, okay, and its value is varying from 0, 0, 0, 0, 1 to 1, 1, 1, 1. And after this value becomes 1. And again, these values will start from 0 and so on, 111. So this is nothing but 31. whereas this is nothing but 0. This is 15 and this is 16. So that means for the first 16 combination, u value is 0. For the next 16 combination, v value is 0. For the next 16 combination, v value is 1. So that is why in order to form a 5 variable, totally how many combinations we have? 32. I need to have 32 cells. Instead of taking 32 cells in a single K-map, I am taking 2 4 variable K-map. So in one 4 variable K-map, I have 16 cells, whereas in the other 16 cells, total how many cells we have? 32 cells. Okay, so these are the 2 variable K-maps, and for the first 4 variable K-map, I am considering v value as 0, which means that for all these cells, v value is considered to be 0, which is common. Whereas for all the second 4 variable K-map, all the cells of second 4 variable K-map, v value is considered to be common, which is equals to 1. So that means, what is the binary equivalent of this? This is 0, right? 0, 0. This wx value is 0, 0. Yz value is 0, 0, 0. So this is the binary equivalent. Similarly, I can write the binary equivalent of this one. V is 0, wx value is 1, 1, and yz value is 0, 0. So what is the decimal equivalent of this one? 1, 1, 0, 0, which is 12, M12. So like that, we can form we can form a 5 variable K map using 2 4 variable K maps by considering the MSB value as 0 for the first 4 variable K map and MSB value as 1 for the second 4 variable K map. Okay, so this is how I can write down the equation. So now if you consider this value, this cell value, so what is V value? 1, and Wx value is 1, 1, and Yz value is 0, 0. So what is the position here? This is 4, 4 plus 8, 4 plus 8, that is 12, 12 plus 16, it is 28, M28, M29, 31 and 30. What is the value of this one? So the V value is 1, Wx value is 1, 1, and Yz value is also 1. All ones, which is 31. So M0, M1, M3, M2, M4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 14, 15, and 16, 17, 18, 19, 20, 21, 22, 23, 28, 29, 30, 31, 24, 25, 27, 26. This is the 5 variable K-map. So what is the maximum possible group that I can form in a 5 variable K-map? I can group all the 32 cells together so that the function may be either equal to 1 or equal to 0. Next possible group is 16 cells. So 16 cells. So I can form all these 16 cells. I can form a group of all these 16 cells, or I can form a group of all these 16 cells. Or else I can form a group of these 8 cells and these 8 cells, because these 2 cells are said to be adjacent. Is it or not? 0, 0, 0, 0, 0, 0, 0, 0, where V value is only varying. That means these 2 cells are differed by only one variable. And these 2 are said to be adjacent. Whereas these 2 are said to be adjacent, these 2 are said to be adjacent. And hence, these 4 are said to be adjacent. And again, these 2, these 2, these 2, these 2, these 2, these 2. And again, these 2, these 2. So, somehow, all these 16 cells will be adjacent to each other. So that is why I can form a group of 16 cells with the first 2 columns of first K-map and second K-map. Even I can form an octet of a group of 16 cells of this 2 and 3 column of both the K-maps here. Similarly, I can form a group of 16 cells with this. Similarly, I can form a group of these 16 and these 8 and these 8. So like that, I can form groups of 16 cells from one 4 variable K-map to the other 4 variable K-map. So don't get confused. So when we are discussing a problem, you will be able to understand. Okay. So this is a 5 variable K-map. So the maximum possible group that I can form in this one is group of 32 cells, and then 16 cells, and then 8 cells, quad, and pair. So these are the possible things that we can form. So group of 16 cells can eliminate 4 variables. Group of 8 cells can eliminate 3 variables. Group of 4 cells can eliminate 2 variables and group of 2 cells can eliminate 1 variable. Okay. So now let us see one simple problem on how to simplify. So first of all, I have a Boolean expression f is equals to summation m of 1, 3, 4, 5. 1, 3, 4, 5 I have. So what kind of, I want to minimize this one using k-map. I want to minimize this one using k-map. Now first of all, we have to identify how many variable function it is. How can I verify this one? What is the maximum value of min term that is present in the function? So what is the maximum value? 5. How many variables, how many binary variables I can use for representing this 5? That is 3 variables. Okay, so that is 1, 0, 1. So can I represent 5 with the 2 variables? No. So that is why this is a 3 variable Boolean function. So in order to simplify this, I need to have a 3 variable k-map. So this is the 3 variable k-map. Let us consider the 3 variables as A, B, C. So 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Right? Now, what is this indicates? This indicates 0, 1, 3, 2. This one indicates 4, 5, 7, 6. Right? Now map the Boolean function with the k-map. So here it is in the SOP form because summation m of sum of products. So that is why it is SOP form. All these min terms which are present in the Boolean function will produce the function output as 1. So now mark all the cells representing these min terms with 1. So this is 1, M1 and then M3, M4, M4, M5. So this is the 1, 3, 4, 5. This is the function. Now, what we need to do? We need to start from higher groups. So, can I form a group of octet, a group of 8 cells? No. Can I form group of 4 cells? Do we have 4 adjacent cells together? No. No, I cannot form even group of 4 cells. Now, I can form pairs here. So, I can form a pair with these two because these two are said to be adjacent to each other because these are neighboring and they are differed by 1 variable. And one more. I can form one more pair with these two. So the grouping should be done such that all the ones should be covered by minimum number of groups. And we need to start from higher groups. So I cannot form group of 8 cells here because only 4 cells are marked with 1. So group of 8 cells is not possible. And even group of 4 cells is also not possible. So next I am going for the pair. Now I want to write down the product term for these groups. So how can I form the product terms? By eliminating the variable which is varying. So for these 2 cells, so I can see that a value is common. For this entire row, a value is 0. So this group is formed by this row. So as a value is 0, I have to consider a value, and as it is 0, I have to consider it as complement. Now let us consider for this cell b value is 0, c value is 1. Whereas for this cell b value is 1, c value is 1. In these 2 variables, b value is varying. Here it is 0, here it is 1. So b value is not common. So eliminate b and consider the common values, common variables. So as c value is common for both the cells, just consider c. And as c value is equals to 1, take it in the true form and form a product term because it is SOP. And now coming to this one, as again a value is common which is equals to 1. So a should be taken in true form. And coming to the b value is 0 here. First column and second column 0 and 0. So consider b which is b complement, where c value is varying which is 0 for the first cell and 1 for the second cell. So eliminate c value. So now after getting the product terms, now I can write down the Boolean function as a complement c plus ab complement. A complement c plus ab complement. Okay, so this is how we can simplify the Boolean function. This is a 3 variable Boolean function. Okay, so for example, the problem may be given as a truth table also. The problem may be given as a truth table. Second one, simplify the following Boolean function which is given in the form of truth table. So I have again 3 variables, or else let us consider, okay, 3 variables. Okay, so f, so it is given 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 triple 1. So this is the function given. So now in this case 0 is 1, next 1 is 0, 0, sorry, it is 1, it is 0, 1, 0, 1. This is the function given. Truth table, in the form of truth table. Now derive the simplified SOP as well as POS. It is a problem given. SOP, POS we need to get from the truth table which is given. So first of all, I want to get SOP. So when I want to get the Boolean expression, simplified Boolean expression in the form of SOP, from the truth table, you need to identify which combinations are producing the function output as 1, because I want to get the SOP function output as 1. So what is this one? This one is M0, M1. So here this function is producing 1. This is M2 and this one is M5. Okay, this one is M5. Sorry, M4. 0, M4, M5, M6, M7. Right? So here, just a second, I'll write it again. Okay. So 0, 1, 0, 1, 0, 1, 0, 1, 0. So now identify the min terms for which the function output is equals to 1, because we are finding the function simplified expression in the form of SOP. So consider the min terms for which the consider the combinations for which the function output is 1. So these are the combinations for which the function output is 1. So 4 combinations: 0, 0, 0, 0, which is 0. Next up 0, 0, 1, 0, this one. Next 1, 0, 0. Next 1, 1, 0, this one. So this is the these are the min terms which are producing the function output as 1. Now what I can do? These two are adjacent, these two are adjacent, these two are adjacent, these two are adjacent. So I can form a quad with all these 4. We can form a quad with all these 4. So now what is the product term that I can write here? As for these 4 cells, A value is not common. It is varying. So eliminate A. Now coming to the B and C values. First column and last column. B value is 0. B value is 1 here. So eliminate B also. Whereas C value is common, which is 0, and hence take it in the form of C complement. So F is equals to C complement. So actually it is a 3 variable function A, B, C. So what I can do here, I can eliminate, as I have formed a group of 4 variables, I can eliminate 2 variables, and hence the final function is having only 1 variable, C complement. F is equals to C complement. Okay, so this is the SOP. Now let us see POS. So for the same function, I want to get the POS. So POS, that means a simplified expression in the form of POS. I want to get 0, 0, 0, 1, 1, 1, 1, 0. Now identify the combinations for which the function output is 0 now. So 1, 3, 5, 7. Okay. So now I'm writing this 1, 3, 5, 7. For all that max terms, the cells should be placed with 0. So 1, okay, this is 0, 1, 3, 4, 2, and this is 4, 5, 7, 6, right? 1, 3. Okay, so we need to place zeros because I want to get POS form. So 1, 3, 5, 7. So now what I can do? I can form again a quad of these. So now I have to write down the product, the sum term, which is nothing but a max term. So as A value is varying, eliminate A. B value is also varying, eliminate B. And C value is common, which is equals to 1, and hence it is C complement. F is equals to C complement. So as I told you that SOP is a dual of POS. What was the expression that I have got? S is equals to F is equals to C complement, and PYS is also C complement. When we are getting a dual, so variable will not be complemented. Only the operators will be complemented. Plus to dot and dot to plus. As we don't have any plus and dot, so simply the function output is equals to C complement. So this is how we can simplify the Boolean expressions using K-map. I hope this is clear to you all. In one of my other lecture, we will discuss so many problems on K-map so that you will be able to understand. And that's all for this lecture. So in this lecture, we have seen what is a K-map and why we are going for the K-map, how to draw the different variable K-map, and how to form the groups, and what happens if we form a group, how the variables are eliminated. So that all we have seen, what are adjacent cells, and how to group, how to form the groups of adjacent cells, and what is the advantages of forming groups. So how can we get what is the procedure of getting the simplified Boolean expression using K-map? We have seen all these. So in the next lecture, we will be discussing some problems on K-map so that you will be able to clearly understand K-map and the simplification of Boolean expressions using K-map. So that's all for this lecture. Thank you, everyone.
Like, share and subscribe. Hit the bell icon for more updates.